Testing, testing, testing. Hi there, guys. My name is Rohan Beve, and today we are going to be talking about gears. Today we're going to be looking at what are gears and the properties behind them. Okay, so we know what the wheel is. Okay, it's one of the most valuable inventions mankind has ever made, and like us, mankind, we also want to improve the wheel, right? We want to improve it for different uses, maybe. For example, let's say we take a wheel and we put teeth to the rim of it. Bam! Gear. We have a gear, okay? Now let's say we take one gear and we take another and we slide them and we put them together, okay? And if they can rotate smoothly together, this is called a gear train, okay? The gear that we turn is called the driver, and the other one will be the follower. Now, notice when you turn the driver gear, for example, clockwise, the follower gear will turn anti-clockwise, okay? Now, sometimes with some gear trains, it could just only be 2 gears, but sometimes there could be 3 gears, okay? That's where the idler gear comes in. What it does, it basically forces the driver gear, not the driver, but the follower gear to follow the same direction as the driver. So the driver moves clockwise, the idler moves anti-clockwise, the follower moves clockwise. Now let's say we have 2 gears, okay, and we put a chain around them. For example, a bicycle. When we pedal, notice something interesting with this property, with the gears and chain. When we rotate the driver gear, the follower gear is also rotated the same direction. That's another property. But you might also be asking another question, okay? Should the gears be the same size to work? No, they could be different sizes. For example, let's look at this gear train, okay? We have a big gear and a small gear, all right? This big, and what happens if we rotate it? If we rotate the big gear, right, the small gear would move 2 times faster. But let's check that out, okay? So in this experiment, we take the 2 gears. We put a line on the radius of each, okay? And they're pointing towards each other. Then we spin the big gear and see how many rotations does the small gear do. If you do it, then one rotation of the big gear, which has 20 teeth, and the second smaller gear has 10 teeth, and it moves twice, okay? That's the property of this, okay? So let's say we'll go back to our example of a bicycle, okay? Or a gear bicycle. We change the gears, okay? And when we do that, the driver gear is more bigger than the follower. So this property occurs, and that means, okay, the faster you move faster, but it will be harder to pedal due to the, due to the driver gear, okay? It's hard to pedal, but in return, you will move faster, okay? And this means that the gear ratio for this arrangement is low, okay? This is low gear ratio. But what is gear ratio? It's basically the driver and the driver gear and the follower gear on top and divided, okay? So if we do it, let's say 10-20, it'll go to 1.5 to 0.5. Hence, it'll be low gear ratio, okay? This basically means that you get more speed but less force, okay? Now let's say we do the opposite. Let's say we switch things up, okay? The driver gear is now small and the follower is bigger. 8 teeth and 16 teeth. Let's do the same experiment again, okay? As we did in the beginning to see the rotations. When we do that, we'll find that the rotations will actually be 1.5, 1 and 1.5. So one rotation on the driver gear will be a half of the rotation on the follower gear, okay? This basically means, okay, if we went back to our bicycle example, we switch the gear ratio to high, which means the follower gear will be more bigger, okay? This basically means, let's say we're going up on a hill, right? It'll be easier to pedal, okay? Since it's smaller, it's easier to move, but it'll be slower, okay? Which basically means that the speed will go down, but the force you can put will be more, okay? Hence the gear ratio is high. That's basically what gears are and their property is, and that's basically it. Thank you for watching this video, and hope to see you next time. Bye bye.